Gaga are an AI and data science company, but she's going to be presenting to you today about backend APIs and testing.
Nothing much about AI, sadly. I can see like we had our share of AI today. So yeah, mostly about backend APIs and testing. I'm Dennis. I'm a backend engineer, so I have done like development for like past 12 years, mostly focusing on microservices and architecture, backend mostly. This is my LinkedIn handle. So yeah, this is where we are going. So we were listening talks about requirement gathering, AI, and data sets, and all that. So this is I'm trying to. Yeah, we should shift our thinking a bit about the systems that we use, what we are actually offering to our users. So it is about serving our customers, and we have like front end and back end. So the front end is the layer in which the users are communicating to the system, and back end is doing all the data processing. So back end is that part of a software that users do not see. And actually, the art of front end is to hide that complexity of backend system from the user, so that it gives them a seamless experience. So, like yes, if front end is the skin of a software, backend is the meat and bones that is keeping it up and running. So ignoring backend, if you ignore backend in your testing process, you are ignoring that big chunk which you are seeing. So just to understand, how many of us do backend testing? Yeah, so that's the backend testing is really important. How we architecture backend systems too. So to encapsulate that complexity, which is underneath that iceberg, we have to structure it in a certain way. And how we do it is using define an architecture. So, I mean, there are many thoughts about monoliths and microservices. So this architecture, that's how we define the backend systems. So you can, I mean, most of the projects, you don't get that privilege to design a system from scratch. Like it's an evolving thing. So we just add functionality to your existing software and it just kind of grows. But monoliths is kind of the legacy decision. Like it was the way we used to build software for a while. And then now industries moving more towards microservices. But yet it depends, it never means that monolith is the way of developing backend systems as monoliths is a bad way of doing it, because everyone kind of like glorify the microservices architecture, but it heavily depends on what your organization need and what your user requirements are. Because microservices comes with its own complications, it's quite hard to maintain. So we should always weigh like, yeah, is it worth this complexity? Is my use case worth the complexity of creating a microservices architecture? Because you can see, this is kind of a simple diagram of how a monolithic system works. So all the components sits inside one system. And you can see that the calls here are like internal calls. There is no calls through the network. So it's very easy to manage. It's very easy to deploy. You just need to write an end-to-end test for one system, and then that kind of tests the entire platform. So you don't need to worry about network errors, or lots of complications are taken away. And they most of the time stores data into one DB. So the entire system, most of the monolithic architecture, we save the data into one database. So it's very simple. And it's easy to deploy, like I said. So but if you want your software to evolve, and if there is multiple teams involved, so like in this example, if there is a accounting department in your organization, and if there is a product department, and you want the accounting department to be responsible for the account surveys, if you want to give them more flexibility, power so that they can choose the technology that they need to develop accounting software. And if they need to choose what they need to use for a product service. So like, let's say like a product service needs a faster read, then you need maybe a database like and accounting service needs maybe Postgres. So if we need to give this flexibility to the teams and autonomy to the teams, monolithic architecture kind of starts to fail. So that's where microservices comes in. So if you can see like this monolithic architecture, we can split into separate pieces. So front end will be a totally different deployable. We can deploy it in a separate container, which is like a Docker container and Kubernetes cluster. And then we will have an accounting service and a product service, and then different teams can manage them. So that is mostly the microservices architectural style. And it should be the services. I mean, there are different ways to create those borders, but mostly it is based on how the teams are organized. Because I mean, software is not just about technology, it's way more about people. So how people are organized, how communication is happening between them. So all these defines those boundaries and what the user needs, of course. So this is like the microservices architecture in a very simple way, from this monolith to the microservices. So here, actually, this architecture is a synchronous architecture. So you can see like the front end is actually calling the account service. So let's say someone brought something from a website, and the front end is your React application, and that React application is calling an accounting service through an API. So that's when we start to talk about microservices architecture. That's when we start to talk about APIs, because that's becomes more complicated once in monoliths, since API communication is internal, there is no network issues. It's quite simple, even though there is APIs in monoliths also, they are just function calls. But once it becomes microservices, your services are maybe geographically apart, you have way more flexibility. So APIs and that terminology becomes more important once we start to talk about microservices. So yeah, that's the front end. So this is a synchronous architecture. Sorry, that's what I was. So that here means the front end gives a request to the accounting service, and accounting service need to give a response back. So front end is waiting for that response, and then accounting service might need to look for a product, more details about maybe its price. So it will call a product service to get the data, and then it serves the front end back. So in synchronous communication, basically the front end is waiting, and these calls goes through the network, and it just feeds back. So there is a little bit of a wait time here. And yeah, I have worked with synchronous and asynchronous architectures, and it is a bit more simpler because we don't have that many moving parts in this architecture. But the local development and maintenance of these systems are quite harder because they are very loosely tied, even though they are microservices. So that's, yeah, the microservices, the term, once we start to look into microservices, yeah, we have to think about application programming interfaces, which are APIs, and they are the doorways through which data exchange happens throughout the network over the wire between the systems. So it's not just the communication. So APIs should be not just the communication channels, they should also be the talking points, because they are the boundaries between the teams. So you need to, APIs should be your conversation starter between the teams. So that's how the communication should happen. Even though we have like microservices give us the flexibility to have independent teams, it's still the communication should be facilitated by API design. And that's when a requirement comes, the different teams need to come together and talk about the APIs. So there are different tools and different processes which kind of enables it. It also heavily depends on what type of API you use. So there is GraphQL, REST, gRPC, which we will talk. So yeah, this and the changes. So once you have a system up and running, any change in the API, it should be communicated to other consumer of provider is doing a change. It should be communicated to the consumer so that their system don't break. So yeah, that's mostly they are the communication channels. So this is like an asynchronous architecture. So where there is the communication, the request comes and the services that is responding to the request, they don't need to wait. So you can see kind of similar to the previous diagram, but the front end sends a request to the GraphQL server, and that GraphQL server will publish that message to a message queue. And once the message is gone there, the front end don't need to wait. It has a local DB, like here, it have a local storage through which it can serve the request of the user very easily because it has that cached information. But the processing of the data just happens asynchronously, and the data is processed by the downstream systems, and then a notification will go back to the front end at a later time. Could be a split of a second. Sometimes it takes ages, to like more time, because if it's like a data science model that's doing more processing, that can go to other systems which consumes the data and all. So this is like much more easier plug and play architecture. So you can easily add and take away services in here compared to the other architecture where it is synchronous. Yeah, so that's, and yeah, that comes to our topic of APIs. So in this in this presentation, you can see like there is a GraphQL API and there are REST APIs. Yeah, so GraphQL API is the layer of communication that happens between the front end and the backend. So it is designed specifically for front end engineers for their, so because in front end, especially React based systems, it's quite easy if we are using a GraphQL API for them to access data, because the data can be accessed in just one request. I'll show you how GraphQL APIs work. So these are, like I said, we have three types of APIs mostly in the industry now, like GraphQL, REST, and gRPC. Yeah, for lack of time, I'm talking about GraphQL and REST now. Just to know how many of us use like GraphQL in your software like development stack, and REST, I think. So yeah, REST is around for a long time, from 2000s. So yeah, it's quite settled and stable platform, but GraphQL is, we use GraphQL in Adaga, and it is very flexible when you compare it with REST, because it is a query language specifically for APIs. So it is built for this, for the front end to communicate with the backend. So, and it's not just the queries, because GraphQL also have all kind of supporting tools. So there is an organization called Apollo, which provides lots of tools to facilitate that communication between the front end and the back end. So there are routers, there are like lots of tools. So when we say GraphQL, it's not just the schema and the queries. There is like an ecosystem which supports that. So what the main benefit of GraphQL is, kind of gives an understandable description of the data in your API. So if I can show, so I'm switching to my editor. So you can see, like, this is a GraphQL schema. So here you can see like this is a very simple API, of course, for demo purposes, but you can see the entire API just in this one file, and you can see like query, which is the way we will fetch the data, and then you can see the mutation, which is the way we will save the data to the system, and you can clearly see what is the inputs that you can query the data with, and how the data, what are the parameters you can use to send the data to also. So the entire communication is kind of encapsulated in a file, and this file can be shared between the front end and the back end. So front end engineers can see this file and say like, okay, your fields are going to be like this. So once this schema can be, so I use a tool called Insomnia, which is very much like Postman. So this is a GraphQL query in a very basic form. So you can see like the schema here, like which is get user feedback query, is kind of translated to this. And then you can add filters like if I say like then I can say one of these fields, it will just give last name. It will just give those back. So it's basically what filters you can pass and then what data we will get back from. I think it's not filtering the last name. So yeah, that's so that is mostly the schema and how the queries are. So this is the mutation. So this is how we sent the data. So you can see like the input here is the structure through which you can send the data, and that can be added here as a variable, and then you send that data, and that gets saved into a database. So that's kind of a very simple introduction of how GraphQL queries and mutation looks like. If you have any questions? So yeah, that's how the schema and the mutations look like. So what's the benefit of GraphQL? Why are we using it? Why are we adding that extra layer of complication? Why can't we just use that? So it's like I said, this is more for the front-end engineers. And you can see like here, I can actually decide what fields to call. So here, if front-end don't want first name, they can decide not to call. And if they need last name, so they have a choice of fields that they need, which gives them more control. But in REST, so this is a sample REST call, the data comes as a big chunk, and they have to like pick and choose what they need to show in the screen. So if you have like multiple consumers like mobile applications and web applications, then this gives that choice for them, so they can pick and choose what they want, which is very easy. And also, and the thing is, this is a very simple query, but you can actually have another query if you want. So you can concatenate queries, and in just one query, you can get the entire data from the backend in just one call. So in React applications, what they do is they just save it in their local storage, and then yeah, they just manipulate it and show it on the screen. So you don't need to do multiple REST calls. So it's quite performant and efficient that way. Yeah, so it gives the clients that power, and it's released in Facebook in 2015. So it's around a while, not that new. It's scary because it's been around, but not as long as REST. Yeah, so the GraphQL queries it's the industry standard way of fetching the data, and mutation is the way to modify the data likely. So so if I can show if the demo works, yeah, I can save it and should I? So you can see that user gets saved here in the and then it gets added to the list in the database. So that's mutation and that's queries. Yeah, most of you know about REST. It is the most commonly used communication pattern in services. It was introduced in 2000. It's around for a while, very stable, and the services that implement this architecture are called RESTful services because they follow certain standards. And yeah, there are like lots of already built-in REST services out there. So if you want to play with, yeah, there is like freely available APIs which you can consume, and it's like a very well settled platform. So you can see this API that I'm calling in Insomnia is yeah, this is from the Rapid API where you can see actually the AI models. It's all out there, and there is like spell correction models. So if you just want to play with them, it's all available and they follow the standards. So yeah, that's about REST. Okay, so I have to bored you about APIs for a while. Now you'll be thinking, where is the testing coming? So yeah, it's just since APIs are important and they are the communication between the systems, that's the place where we should test them, because that's where API systems testing becomes more important. And yeah, you all know the testing pyramid, but I'm not talking about the end-to-end test here. Just wanted to show you how unit test, contract test, and integration test can enable us to use the end-to-end test if you can. Like, I don't know how many of you have like full confidence on the end-to-end test you run in your organization. Like they are flaky, they take ages to run, and it's hard to maintain. You need to spin up the entire architecture to run them. So sometimes like, oh, 2 tests are failing, it's okay, you can ship it. And that's what happens most of the time. So if we have confidence in this lower layers of the pyramid, unit test, contract test, or integration test, then we have only the happy parts for the end-to-end test and kind of make it less flaky and yeah, easily maintainable. So if I can show you how the unit tests are written in a backend system, just to give you a taste of it. So you can see, like, can you see?
Increase the size.
Like, where's the it's better, maybe not. So can you see? I think it's harder to see. So yeah, then we do this is like a simple unit test for this service, which we've just actually listing the users and saving the users. So this is actually to save the users. So these are the unit tests. And what we do in unit test is we are kind of mocking the database layer. So we are kind of saying, like, let's pretend the database is not available. What will the function do? So that's the kind of how we write unit tests. And we kind of like, so this service actually depends on a SQLite database and a Kafka queue. Those are the 2 external dependencies of this one particular service. But when we write the unit test, we kind of say, like, okay, we pretend we mock the database and the Kafka queue, Kafka or the message queue functionalities to say that, okay, it's behaving this way, what you should do. And that mocks kind of help us to handle the errors gracefully and have more coverage over different scenarios. So that's how we write unit tests. The amount of coverage you can have on the unit test kind of increases the confidence in your system. So it is very much, yeah, part of the testing framework. It should be part of the testing that you do. That gives, like in the pyramid, I showed, it is the basic layer. So yeah, and then the next layer is the integration test. So in integration test, so yeah, we saw in the talks like where BDD scenarios are generated. So integration test kind of follows that BDD scenario. Once we take that BDD like this, one of the test cases, I have written just one for the simplicity of it. And then we kind of, once the test starts to run, we have to bring up all the dependencies. So when I talk about integration tests here, it's not different services, it's different moving parts within one service, because that service is talking to all this database and the Kafka queue. So this is, it needs to bring up a container for the database, it needs to bring up a container for Kafka, and then we bring up the service and then we kind of run it to see whether the data is getting saved or not. So yeah, have used Go, but it did this Gherkin language, and the support to generate the tests are available for, I think, almost all languages. So yeah, this test kind of test what we saw in Insomnia here, where we can save the users and retrieve them and run it. taking a while. So that's these are the two. So you can see like we are bringing up the containers, and then it's bringing up Kafka. And then it's trying to save the data to the database, which is a SQLite database, and then it will try to publish the message to Kafka. So you can see like, yeah, that's and then we can see like there should be a text file which is generated and which will have the data that we have defined in our feature file for the so that user gets saved usually. So that's integration test. And then there were lots of talks about packs and contract testing. So just to touch on that, it's contract tests. And since the service can be used as a provider, we can have like contracts defined in JSON files like this. And we can use that file. So this JSON file will be generated by the consumer. So we can run the contract test in the consumer. The consumer will create a contract, and that contract can be used to check the provider. So this is the way to test that API integration layer where the communication is happening. This is the simplest way of testing. Does anyone of you use contract testing? Yeah. So how do you use Pack Docker or?
We use packs.
JSON file, or you use the broker?
We use a broker.
That's a way of doing it because that's saved and it gets updated automatically as part of the CI pipeline. Yeah, so that's another way of testing the APIs. So yeah, I have. This is how the APIs are working, and I have like a basic React app, which is the feedback form. And I can say like how this is how the user sees it. I mean, it's a very simple application, but you can see like how this app is talking to the backend. So if I can go to Visual Studio, you can see like there is a query that we see in now, which is here. You can see them in the front end. So the front end is actually calling these queries from GraphQL as such as JQL calls, and that data is loaded into the form, gets saved into the DB. So this is how the communication is happening. And yeah, that's mostly it. If you have any questions, I'm happy to answer.
I have a question regarding contract testing. Can you use this technique for like, you mentioned Kafka, right?
Yeah.
So anything that comes on Kafka or Kinesis or any sort of message bus, is there sort of contract testing you can apply to those?
Yeah, you can run a test. So for Kafka communication, we are using a kind of a stream processor. We use behaviours, which is kind of a way to decouple the Kafka dependency from your microservice. So when you bring up your microservice, you don't need to worry much about Kafka. So the behaviours that we can run tests as part of that stream processor. So stream processor can have that contract, which is what is actually accepting the request from Kafka. So the service is, we need one service which will have that queue dependency. And once that message is published, the stream processor will pick it up from Kafka. And for when you change the stream processor, yeah, we need to understand. So we can run the contract, and that's the layer where we will test. Yeah. Yeah, I have all this demo code in GitHub in this repository. So we can have a look. It's not a real world application. It's just demo and to see how these different parts work and how they are defined. Is sometimes we feel like, why do we really need GraphQL? We use REST because but they all have their capabilities. And sometimes we really need to do gRPC also, because if there is an authentication call or token validation, and if there is a service which is generating those tokens, then you need gRPC services so that they can talk each other and get valid tokens. So on those scenarios you really need gRPC. You cannot kind of work with REST because REST is very slow. And there are security issues also with REST. So each of them are those communication layers. They have their use cases, but you don't need to be like mad about it and like, okay, I'm going to rewrite everything to GraphQL. That is also not needed. You just need that upper layer where the front end is communicating with the backend and in gRPC so that they can just communicate quite easily and efficiently. So it's not like, yeah, one thing is magic and that's going to solve and make everything simpler, but it's kind of a mix and match. That's where we are going.